Hi guys, I'm back with an update to my FoxHole artillery calculator for the game FoxHole. I'd like to show you the new features that we've added. The first thing that you'll notice is that we've added peer-to-peer syncing. This unfortunately means that we do need a server. You can find the code for the server on my GitHub repository under FoxHole server. So if you click on the connection state, you're going to set up a new peer-to-peer sync. You need a server address wherever you're hosting that, and then you need a sync code which determines who you're going to link up with, who you're sharing your data with. So I'm just going to enter in mine here. And you'll see my URL has changed. If I simply copy that URL and send it to my friends, they don't have to go through this process. You can just paste in the URL and we're connected, as you can see. Okay, so now that we're connected up, I can create an artillery piece. As you can see, it's syncing to both clients. The performance is very good. Full disclosure, this is a local connection, but you can expect comparable performance. Once you've got your artillery in place, you're going to create a spotter. So, if you have a single one-man spotting for your artillery, all you do is you create a spotter for him. You'll see they each have a name generated. So if Kels can see the artillery piece, we just look for the readings from Kels to the artillery, and we enter them in here. So he runs out into the field, probably until about 100, and he can put in his distance and his azimuth. We'll just leave it at 137.7 for now. Then, from here, he can look ahead and find either an enemy, or if the enemy is further away, which is quite often the case, you can simply look at any notable feature which you'll be able to look at in the future. So let's say we find a watchtower or a peculiar looking rock. We can find its location, create a new spotter at that location, so it's 106 from me, and I'll say that its azimuth is, let's say, 357. That's the rock's location. I can then run further into the field, create another spotter, and looking back at the rock's position, I can create my location again. So I can just repeatedly find notable features to track my position in the field relative to the artillery. Then, once I finally spot a target, I create one relative to my position. I enter in its distance and its azimuth from me, and you'll see it's synced across perfectly. And if I hover over the artillery piece, it draws a firing arc, it tells me the distance I need to aim at and the azimuth that I need to aim at. I can also hover over the target, because if there's multiple targets, and I hover over the artillery piece, it can be confusing. So you can also hover over the target. Just going to delete that. Finally, you can either pin the artillery or the target to just keep the firing arcs visible at all times. You can pan the viewport, scroll, rotate, etc. You've got a compass which is true to the in-game directions. If you click on the compass, it will rotate so that you're facing north again. Okay, so the artillery is now dialed in. He knows exactly the target's position relative to himself, assuming that all of these measurements have been accurate. There's some degree of error, obviously. Binoculars aren't the most precise things. They don't show us fractions and distance, for example. But additional to these inaccuracies, FoxHole has wind, which blows in some direction, and the intensity and direction change over time, which will then cause us to become increasingly inaccurate. We've got a way to accommodate for this, however. Once we've created the target, we can click on this button over here to tell the artillery, we're happy with our measurements, please fire. The artillery will begin firing. Now, this spotter, Fife, knows Bryce's position relative to him. He knows it's 92, azimuth 328, or sorry, 328.8. If the artillery fires, and it just so happens that the wind is blowing in the northeastern direction, the shot's going to land somewhere out here. Now, there is some variance, so you can't just use one shot, but let's say you fire 3, and on average, they land about here. What you can do from the spotter is create a landing zone. You'll see whenever you edit a unit, the firing state becomes not ready, you need to finish editing and then tell the artillery you can shoot again. So, the spotter has sighted out the target, the artillery has fired on these coordinates, and it's actually landed at this position relative to the spotter. This is a landing zone. It's designed to indicate where shells are landing. You'll see that when you're looking at a target, a spotter, or an artillery piece, there's a delete button and a pin button, as well as buttons to create new units relative to this one. Firing zones, on the other hand, have an edit wind button. So, this landing zone is, let's say, north-north. It's approximately northeast of our target. If I click on it and say update wind, it's going to delete this landing zone. It's going to change our wind measurement to point at that angle at the distance that the shells have been moved, and the distance and azimuth of our firing arc changes to accommodate for that. So now the artillery is approximately aiming over here. Then I can say, ready to go, please fire some more. The artillery continues to fire, and let's say my average was slightly off because, you know, there's variance, that's fine. So I was off by a bit, that's fine. I can create a new landing zone again and say, now on average the shells are landing here. And when I click update wind, it takes its position relative to the target and it adds it to the previous wind accommodation. It doesn't replace it, because obviously the shells landing here are a result of this firing arc and the previous wind accommodation. So I simply click update wind and you'll see this distance and azimuth will change. The artillery can now accommodate and fire at the new position, accounting for wind. The beautiful kind of side effect of doing it this way is we don't only accommodate for the wind, we accommodate for all inaccuracies. Let's say that when creating this position, we accidentally mismeasured the distance and said that it was 90. The target is now further down than it used to be. In fact, I can make this a lot clearer by leaving in the previous measurement, create a parentless target and just leave him over there. Now when I change this to 90, you'll see we've got some inaccuracy now, right? We've messed up. Our firing arc is wrong. When the artillery fires, their shell is going to land over here, right? But we think we're aiming there. The target's actually there, but because this guy messed up, we're firing too far south. So our shells are landing here when the target is really over there. We simply create a landing zone where the shells are landing, so it'll look like this to us. Adjust for the wind. There's multiple targets, so I have to tell it which one. And it will fix our measurements for us. So we can account for wind, we can account for measuring inaccuracies, and the correction amount is cumulative. So if the wind is really strong to the northeast, you get some landing zone, you apply it, it fixes your numbers to some degree, you get ready, you fire some more, and you can see how well you've corrected and improve it by just making another landing zone for where your shells are landing. Then, when the target is destroyed, the wind reading remains. So this target is dead, we delete it, we make a new target. Let's say we're aiming at a different tank. It's still using this wind measurement, so it's still correcting for any inaccuracies up the line. It's still correcting for the current wind, and as the wind changes, we just create more landing zones to show us where the shells are landing and fix it. This will allow us to very, very quickly sight in our artillery, keep our wind measurements accurate, and just hit people dead on every time. Additionally, when you're fighting a bunker base, you don't want all your artillery in one position ideally, because their howitzers are going to destroy your artillery automatically. So if you split up your artillery into 3 separate positions or more, you can simply sight them all in. I should create that from the spotter. So we have 3 different artillery setups, not next to each other, so they're not vulnerable to howitzer fire should one of them land. Then one of our artillery squads, let's say, opens up the utility and his position is over here, he pins it. A different guy's position is over here, he pins that. and they see their own firing lines. So this is Dang, he sees his firing line. This is Fife, he sees his firing line. One of them can fire. You can account for the wind and the measurements, get everything dialed in, and then all your artillery, which has been spread out, opens fire on the bunker base to destroy it without getting retaliated on while it's trying to retaliate to Fife. So you can spread your artillery out, you can fire long distances with a single spotter, you can account for wind, you can account for measuring errors, and you can sync peer-to-peer what your firing arcs should be. You can sync when you're ready to fire. And if you get disconnected, this button will update. It will say disconnected, and after 10 seconds it will try to reconnect. Or you can just refresh the page, and it's already synced back in. Thank you for watching. Please let me know what you think.